Hey, 7th graders, today's lesson is 2.3 microbiomes. Your learning targets for today. I can describe the effects of antibiotics on the human microbiome. So we're really going to start digging into antibiotics and how they affect good and bad bacteria. Okay? Moving on, one of your bell ringers for today was your notebook. So you needed to add key concept number 7 and number 8 to the key concepts page of your notebook. Key concept number 7 says a healthy microbiome has various helpful types of bacteria. And we'll talk about how those bacteria are helpful. What do they do to keep us healthy and kind of keep our bad bacteria at bay? And key concept number 8, an infection of harmful bacteria in the human microbiome can make a person sick. Like I said, you guys are also going to learn a little bit of how antibiotics tie into that. So for your warm-up today, you guys have 2 arguments, and you're going to tell me which of these arguments is more convincing. So argument number 1, patient 23 felt sick during week 3 because he was infected with the C. jejuni bacteria. From the Human Microbiome article, I know that this kind of C. jejuni infection can cause diarrhea, vomiting, and fever, all the symptoms of food poisoning. These symptoms match the doctor's note for patient 23 for week 3. So you guys saw that little pie graph where we saw week 1, what a healthy microbiome looked like, and what week 3 looked like, where we saw that orange piece of the pie that was C. jejuni, which turns out to be a main component in food poisoning. When patient 23 felt healthy during week 1, the C. jejuni bacteria was not present in his gut microbiome. However, in week 3, when he felt sick, C. jejuni was present. Therefore, C. jejuni is probably the cause of his sickness. So we're really focusing in with these 2 arguments of why was patient 23 sick at week 3 but not at week 1. Argument 2, on the other hand, patient 23 felt sick during week 3 because he was infected with the C. jejuni bacteria. C. jejuni is very bad for you. He probably ate something spoiled. My sister got food poisoning once. Okay, so you have 2 arguments, and while I'm sure both are compelling, one is clearly the better argument. Okay, so I want you guys to take your draw tool and you'll either circle argument 1 or argument 2 if you guys haven't done this already. Make sure anytime you use your draw tool that you click back on your cursor and explain your thinking right there. So click and type why you guys felt that way. What was different about those 2 arguments that clearly made one the winner and the other one not so much? Okay, remember that when you guys watch these videos, at any point you guys can pause them to do the activity, and then you guys can hit play when you're ready to move on. With that being said, we are going to move on to activity 3, which I dubbed the effect of antibiotics. Okay, just kind of thinking about it, if you've ever been on antibiotics, maybe you're already kind of familiar with what they do, but we're going to take a dig into them with a little bit of evidence on an evidence card sort. So this is the antibiotics card sort. If you guys were in class today, obviously you're probably not listening to this video, but we did this with actual physical cards. Okay, you guys are going to be doing it on your computer to show me that you guys kind of read through that evidence. So how do antibiotics affect the microbiome? So your claim today is that antibiotics cure infection by killing all types of bacteria in the body, including the harmful bacteria that cause the infection. So if we're looking at patient 23, okay, and he's sick, essentially based on this claim, we could feed him some antibiotics, and with that being said, it's going to kill the harmful C. jejuni bacteria, but we're also going to see that some of the good bacteria get killed as well. Okay, so we're going to see if this claim is true and if that, in fact, is what happens with patient 23. So for your card sort, you guys will have the claim card at the top. You obviously aren't using your desk, you're going to be using your screen. And then below that, you're going to see a column for relevant and irrelevant evidence. Okay, so remember, relevant means it's important, it helps support this claim. Irrelevant means it's not important and it doesn't really help support our claim. Okay, with your partner, obviously you guys are doing this by yourself at home. Discuss each evidence card and decide if it is relevant or irrelevant to the claim. If you guys aren't really sure if it's irrelevant or relevant, you guys can kind of leave it in the middle as well. Place each evidence card under the appropriate header on your desk. So here are your 6 evidence cards. Okay, so we've got evidence card A. Often doctors treat infections with antibiotics. Antibiotics are medicines that kill bacteria. So that was a quote directly out of the human microbiome, which we read in 2.2. Evidence card B, the number of bacteria in the microbiome of one human is millions of times greater than the number of people living on Earth. That's a pretty interesting fact that also came out of the human microbiome. Evidence card C, also out of the human microbiome article that we read in 2.2. Unfortunately, not all bacteria are helpful. Harmful bacteria can invade the human microbiome through cuts, spoiled food, and even the air we breathe. An invasion of harmful bacteria or other microorganisms is called an infection, and infections can make people very sick. And evidence card D, even though they are so tiny, bacteria are living things. They have the same basic needs such as food, warmth, living space as all other things. And then we've got evidence card E. You guys have this picture, which you guys have seen something similar to that. That is one of those eyelash mites that I showed you guys in 1.1. The little caption under that picture says, this microorganism is an eyelash mite. It is harmless and lives next to the roots of the organism's eyelashes. This photo was taken through a microscope, so the mite in the image is about 300 times larger than its actual size. And then finally, evidence card F. We have a Petri dish here. You guys should be somewhat familiar with those after growing some cultures in class. Okay, what we have in this, unfortunately, when we did it this year, I didn't have any antibiotic discs, so you guys couldn't examine this. You guys have bacteria growing all throughout this Petri dish, and then each of these little white circles is what we call an antibiotic disc. So those have been placed all around the culture, and you guys can see the effect that they've had on the growing bacteria around them. Okay, so again, your claim is that antibiotics, so your focus is on antibiotics, cure infections by killing all types, not just good or bad, of bacteria in the body, including the harmful bacteria that cause the infections. So you guys are going to click and drag and sort these pieces of evidence. So either relevant, which you mean you think it's important to support this claim about antibiotics, or irrelevant, doesn't mean it's a bad fact, but it just doesn't help you support that claim. So go ahead, drag them back and forth. If you think it might be somewhat important, but not super important, you guys can even kind of keep it in the middle of this as well. So go ahead and sort through. It's okay if you guys have them overlap a little bit. You guys can stack them up here if you want as well. That's up to you. All right, moving on to activity 4. This is visiting back to patient 23. So this was the pie charts that you got a little earlier that showed us, all right, here's week 1. This was when patient 23 was a healthy individual. You guys can see what his gut microbiome looked like. Week 3, this is where he gets food poisoning. He has C. jejuni now present in his stomach, which is wreaking all sorts of havoc with his vomiting, diarrhea, and of course a fever. So as you will soon see, patient 23 was treated with antibiotics after he got sick during week 3. The question we are going to investigate is, how do antibiotics affect the human microbiome? So we're going to kind of check in on that claim that we just did some evidence on and see if that is in fact true. Okay, so I want you to just think of this. If we were to treat week 3 patient 23, the sick guy here, with antibiotics, what do you think his pie chart might look like after he's been on antibiotics for a week? I want you to just think about that before you guys move on to the next slide. Okay? All right, so here is his pie chart for week 5. His treatment he underwent was antibiotics. So you guys can see that he has some bacilli, which we're going to learn about is L. reuteri. We have Bacteroideaceae. That's literally small for me too, which includes bacteria like B. fragilis, which we'll also read about why it's important in our body. We've got actinobacteria, which is B. animalis. We've got gamma proteobacteria, including E. coli. So you guys have probably heard the term E. coli before. He's not sick from that E. coli. So we normally have E. coli in our bodies, but when we have a large amount of E. coli is when we get sick. And then we've got other, okay? So notice that we have basically lost most of our bacteria, okay? So examine that closely, and then what I want you guys to do is answer these 2 questions. Observe what happened to patient 23 during week 5 after he was treated with antibiotics. What did you notice? Okay, so you'll answer that question right there. And how do you think antibiotics affected his microbiome? Okay, answer that right there. And then moving on, do you have any questions? Circle yes or no. If yes, type them below. And then 4, 3, 2, 1, how do you think you did on this assignment? And you are all done. You can turn this in, but don't touch your face. Have a good day. Bye.